As Giannis just said, my name is Charles Hall. I work at Pearson. These are my two colleagues, Margaret and Meaghan. And we are here to talk about how our system or our product Mastering integrates with MarvinJS. So Mastering is an online homework platform that science users across disciplines use. Primarily college age. We do have some AP level courses. But we span the gamut from your health and nutrition courses to physics, which is where we actually got our start, and then, of course, to chemistry, which this audience cares most about. So we have 12 main disciplines, and based on the numbers showing here on the slide, you can see that chemistry accounts for a little over 1/6 of that total user base, even though it's 1 out of 12, so it packs an outsized punch. It's very important to us. And the drawing capabilities that MarvinJS provides are a key component towards, providing the educational content that we need to keep our users. So I'm going to let Margaret tell you a little bit more about that.
Thank you, Charles. I'm Margaret, and I would like to talk to everyone about the power of mastering. So you've just heard a lot about the strengths behind ChemAxon software, and when we integrate MarvinJS with mastering, we have a robust tool that can grade a variety of student inputs. So this example right here is showing I'm sure everyone expects that we can do exact matches. We have an author can code an exact chemical formula. If the student matches that chemical formula, if it's correct, they're correct. If it's wrong, we offer feedback. That the aim is to guide students to be able to, they read the feedback, they'll go back, they'll analyze the question, and they'll hopefully, with the additional information, be able to get the question right and understand how to move forward in this problem. The evaluators don't just do exact matches. We're able to also analyze pieces of structures. So if we know, for example, that the student's predicting a product, and this product has a specific chemical formula that we're expecting, and you can predict the formula based on the reagents, we can actually tell the students that this chemical formula is incorrect and target more generic feedback related to that misconception. If we have predicting that, creating a carboxylic acid, we can tell students that, these reagents, you're looking at an oxidation, you expect a carboxylic acid, this is why. The students can look at the information, go back, analyze the reagents, and be guided towards the correct answer. We also have more generic feedback that guides students. So the more generic feedback, this example is with valence errors. So the system is calculating on the back end whether the octet rule is met or not met. If it's not met, then the student gets this more generic feedback. Our authors don't have to write this. This is in the system. Any student who's using a problem, whether it's a problem where we had a lot of attention to specific misconceptions or whether it's one that had less attention, like an end-of-chapter question, all students have access to this feedback. Depending on the level, our authors can actually decide whether we want to highlight the valence error or not. So if we have a complicated synthesis, we want to make sure that students are focused on the synthesis. We're very conscious of cognitive load, so we want the students to focus on the synthesis. Did they get the right functional group? Then we may highlight that error for them so that the student can more easily see where they made their more beginner-level error. But if we have a beginner-level question, then we're not going to highlight that for students. We're still giving them the feedback, but we won't highlight where the error is. So the student is working through, at the level where they are, the most important steps to the problem. Mechanisms, students really appreciate that the system can actually predict the product of a mechanism. So in this particular example, the student made an error in the first step, and we highlight where the error was made. And you can see that the student did not include a curved arrow breaking that hydrogen-chlorine bond. So we highlight that the step where the error was made. We have information telling students approximately the type of error, whether there's too many electrons being shared, if there's too few electrons being shared. We do try to give them some information about the type of error that was made. But the important piece is this link that says, see the product. So the students can click that link. When they click that link, they're shown what the products of the highlighted step are. And then they can go and see, okay, this is the product that was predicted based on the curved arrows. They have this extra bond. So hopefully they can use that to go back, look at what they did, and correct their mechanism. I'm actually going to take a step back. Since I'm talking about what mastering can do, we're talking about the feedback that's available to students as they work through a problem. Our goal is to work students towards the correct answer. We work towards mastery of these concepts. And as part of working towards mastery, we also offer hints. So depending on the problem, students have available to them a series of hints that will go back. Either it's a step towards solving the problem, or they might have a hint that is a topic of a previous chapter that they need to master in order to continue and answer these questions. And some of the problems have the links to the misconceptions right in the feedback. So some feedback will have a link to the specific hint that the student needs to remediate right there. If there isn't a link to a hint, then the student has a list of all the hints available for that particular part, available from the main part. There's a link right there. So this is an example of a list of the hints that would be available for a main part if the student clicked that link. And then they can go in and answer a question that helps remediate previous concepts. Sometimes these are also steps towards solving the problem. And this, by working through these more remedial steps in their problem, the students can then go back, analyze the part, and again, our goal is mastery, to get students to working towards the correct answer. So back to mechanisms, in order to help students to identify the mechanism that they're drawing, to make sure that their electrons are correctly placed, we do try to focus on the electrons. So we do have a lot of author settings. I talked about valence. The author can choose whether to display that valence error or not. For mechanisms, the lone pair electrons are always shown, because that's what's important. The electrons are flowing. So the setting is an author can control this setting. The students will select the atom, and the electrons around the atom will be available to select, to show that, so a student understands that selecting, lone pair electron or radical electron, they have to select the electrons from that atom. If it's a water molecule, there'd only be 2 lone pairs of electrons in the oxygen. So whatever electrons are available, that's what will display when the student clicks on the atom. They select the electrons that are going to flow, which in this case, they want the single radical electron. And then once they click off the atom, then they can drag to the curved arrow to show where they want those electrons to go. In order to help guide students so they understand where their electrons are going, we have dotted lines so the students can see that this is where it's starting, this is where the electrons are going, so they can feel secure when they submit their answer that they know this is what I am telling the system. I talked a little bit before about our custom displays. So we're conscious of cognitive load. We want to make sure the students see what they need to see when they need to see it, but if they don't need to see it, we'll hide that information. So if we have a question that's a synthesis question, we may have a skeletal, ask for a skeletal answer. So we would have this, set the system up so it's the carbon atoms aren't showing, hydrogen atoms aren't showing. When students draw, they'll just be drawing the skeletal structure so they can focus on what's important for that problem. We can display hydrogen atoms only on heteroatoms if necessary. So we have a lot of options. We can show lone pairs, hide lone pairs. We can show valence errors, hide valence errors. Our authors have a lot of options here when deciding what is the best way to grade this problem, what's the best way to set this problem up. We also think about that as far as what menus are available to students. So this is an example of our 2D menu palette and our mechanism menu palette. There's also another set for skeletal. I'm just comparing these two. You can see that we have additional set of 3, the boxes, the arrows, and the curved arrows available to students if they're working a mechanism. They don't need those when they're working a skeletal structure. So we hide those so we don't have any, we avoid confusion, reduce cognitive load. The students are focused on what they need to focus on. So I'm going to hand this back to Charles to discuss basic system architecture. So thank you, Charles.
So yeah, basically everything Margaret was just telling you about is kind of driven towards our end goal, which is providing students with content that allows them to kind of get hands-on with the chemistry more so than what we could do with, like, say, a multiple choice answer type or some of the other content that we have. And there's quite a bit of, back-end integration that goes into this because, I think fairly uniquely, we end up hooking Marvin's front-end UI with a system of evaluators that Margaret was just telling you about so that we're able to assess the validity of what students are inputting. So we've integrated the UI into our content player, which is where all of our questions appear. And it looks pretty seamless the way that we've done it. A student wouldn't be able to tell that now they've gone from mastering into Marvin. It all looks like one page. And as they're inputting information into that, it is flowing through to us, and there's evaluation requests, which are basically when they submit their answer. The other requests are things like authentication, make sure that they should have access to this. And then those types of requests get sent over to where we link up with JChem and with our evaluator code. And then with the evaluator, we're able to assess this is correct or this is incorrect and give the appropriate feedback. And so going off of that, the next thing that we want to talk about is a big priority for us at Pearson, and I was glad to hear Effie highlight accessibility in the 2019 goals for MarvinJS, because for us it's critical. The universities that we partner with are mandated to provide accessible educational experiences to their students, and so it always comes up when we're talking about why they should go with us versus our competitors. We've spent a lot of resources in the last several years trying to bring all of our content and platforms up to what's known as the Web Content Accessibility Guidelines. And so we can't say that we are 100% there, but when we show our universities where we are versus where some others are, we tend to look ahead. We tend to look better, and it's something that has actually been a driver of business for us. So, not only is it the right thing to do, but when you do the right thing, people pay attention. But a big challenge for us has been drawing tools like MarvinJS, but not just MarvinJS. We have a number of drawing tools. But so just to kind of highlight things that we're looking at, and Effie did mention some of these things earlier. A big piece is keyboard and screen reader accessibility, where a user can actually tab through, and as they're tabbing through, you would have focus on the elements they're tabbing through, like in the image here, so you would see it highlight as you're going through. And if they need a screen reader, if they're blind, everything would have all of the images that they're tabbing through, all the options would have appropriate alternative text that would announce what it is that option's doing. So those are two key things. In addition, the color contrasts of the menu items are important. We want to make sure we're using colors that someone with color blindness would be able to distinguish. And now I'll turn this over to Meaghan.
So I'm going to talk to you about some of the future directions and hopes that we're hoping to head with our relationship with ChemAxon and MarvinJS for future generation products. Currently, as Margaret talked about, a lot of organic skeletal and mechanism-based questions. Our hope is in the future to extend our relationship to include drawing of Lewis structures for general chemistry. And this includes things like grading lone pairs of electrons. So right now we can toggle them to display on or off, but the system cannot grade whether the student draws them or not. They are either sort of automatically there or not. So looking to be able to allow students to have either a lone pair or a single electron and be able to place them on the appropriate atoms and be graded correctly, as well as brackets for ionic species. And this comes up for us quite a bit with our GOB level texts. A lot of these texts are for health science students or introductory level students, and they don't formally teach formal charge. And so they teach primarily this bracket notation with the ion associated on the outside of the bracket. So we would hope to be able to include this in our Lewis drawing feature so that we can move a lot of these questions out of a multiple choice type format, because right now we can't allow the brackets. So mastering today as far as synthesis looks and getting students to predict either products of synthesis or starting materials look like these sort of maps where students have precursors or have boxes where they can fill with a particular structure. And oftentimes we have to indicate to them the reagent and then they predict the product. But the hope for the future is to also be able to sort of work in the reverse, where students will have a drop-down menu of possible options of reagents to be able to predict the reagents needed to go through a series of synthesis steps. And the hope with that is to be able to expand use in second semester organic chemistry. because for instructors teaching class and structuring exams, they often structure exam questions in many ways, where students are predicting the products or drawing starting materials, but also looking at reagents and choosing the most appropriate reagents. So this is something else we're thinking about for next gen. And the last thing I'm going to talk about is a feature that we've all sort of been talking about over the last couple of years, which is looking at building off of what Margaret showed you with the predictive mechanisms. And the hope was that students would be able to have this type of environment in a low stakes sort of study area type concept. So right now, students, when they enter into any type of online homework or even on paper, they're acutely conscious of making mistakes and being penalized for it. So we're hoping to develop an environment where students can practice mechanisms without the fear of being graded, so that if they were to draw, for example, a couple of steps and click on show answer, that it would predict the product of what they had shown and allow them in real time to make modifications to their original arrow flow or reactants to end up with the desired product. And I think that that would also help expand to second semester organic chemistry. And this is the contact info for the portfolio manager that's in charge of our organic chemistry content, Chris Hess. If any of you were in San Diego, he was there presenting. Thank you.
So you mentioned that chemistry was approximately 500,000 and you had like 3 million total. What is the highest area that you have subscribers in?
In chemistry, you mean, or in the total platform?
In the total platform.
Oh, that's a great question. Well, so our largest 4 disciplines end up being physics, chemistry, biology, and A&P, and they all kind of share similar user counts. I'm trying to think, but in the breakdown of chemistry, do you two happen to know if, like, say, general chemistry or more advanced chemistry tends to have more users?
I would say that general chemistry has the most users of the chemistry subdisciplines. Organic chemistry, I think, is I try to. So GOB has a lot of organic in it as well. So I'm trying to decide. I think organic would be tying for second, probably.
Yeah, probably.
Yeah, but so no. Well, Pearson has another system that handles math content, but not us. No.
Yeah, we're just science.
This is an interesting product, and I think the proper emphasis on student education. It's really great. I think there's a large market for adult education too, especially in the and probably you're already using the product this way for just industry professionals. So, for example, anyone who's not a chemist who does drug discovery, I think at some point wishes they knew more chemistry, or just to follow along in discussions and how deeply can you go to understand those. So I was thinking, not only for biologists, but computational people who aren't chemoinformaticians. They're just somebody who has excellence in programming that could more rapidly pick up elements of chemistry by doing this. And it seems well tailored to do that, although the modules that you would do to put that together might be different than basic chemical education. It's not necessarily drawing electrons or even identifying the correct structures, but it's a different viewpoint for what the curriculum would be and what the utility would be. So it's just a suggestion for matching this great start that you have with a potential need.
Yeah, and I mean, in recent years, we have seen a larger share of our users becoming like returning education students. Not necessarily quite the use case you're describing, where it's like a professional who's not going back to school but is just trying to self-study. We do have self-study registration. It's not quite as robust as what happens when you're in a course, but that is something definitely for us to think about in terms of expanding.